All right. And we'll turn it over to, I think you should be able to share.
You all hear me?
Yeah.
Okay, perfect. So, hi everyone. Good morning, good afternoon, good evening, whatever you are. Today we're gonna talk about go further in this spatial statistics or spatial analysis 101. I want to apologize because my voice is not the best today. I have a runny nose and a sore throat, so if it's hard for you to understand me, please let me know and I will repeat it, of course. So today, we're gonna talk about GeoDa and how to um, create rates and how to visualize those rates, both on QGIS and GeoDa. So first things first, let's start with what is GeoDa and why it is a important software. So let me change here. I So if you go to your browser and search for GeoDa, you end up like this, and then the first website that pops up is geodacenter.github.io. So GeoDa is a software developed by a geographer called Luke Anselin and his team, and it's currently based on University of Chicago, I think. I'm not completely sure about it. Uh, but the main goal of Dr. Anselini on creating this software was to be able to perform the analysis called autocorrelation, Moran's autocorrelation, which was first introduced by Dr. Anselini. So this is a very simple, very easy to use software for spatial statistics, not so much for spatial visualization, but we'll get to that. And it's now on its, I think, 22nd version. So it's now available from September, the last updating, 1.22.0.21. So to download GeoDa, you go to download, and you can choose for Windows, for Mac, or for Linux, and then just choose which one is best for you. But there's a thing here. Whenever you download it for Windows or Mac or Linux, for Mac is not the best. Uh, it's not like it doesn't run, it doesn't work. It does, but from I think this last update, it started to demand C++ visualization and some coding. So C++ is a code language that is very common for any type of graphs and visualizations. And it's not the best for Mac, but also works. So it will start and then we'll try to install it, and then it will ask us to rerun the computer. So it's okay for you to download it today. Don't try to install it because it won't be able to open it today. So for sake of time, I won't wait for you. But feel free to let me know if any error occurs when you try to install it, or if you try to run it or do to replicate the class today. So GeoDa is an amazing software, but it's also very complicated to understand in the first try. So I already have downloaded, of course. Let me show you here. I mean, you already saw it. This is the software. So it's not what we expect when we open a software, a GIS software. And of course, it does a lot of things happening with just this, let's call it rule of things. But the first things here we want, I'm gonna close it and open it again so you can see how it starts. So it starts to creating this, to open this connect to data source. So it asks for a shapefile or any type of spatial file that we can insert here. So you can input a file. If you click here, you can see the different types of files that you can insert or input. Of course, the most useful ones is the shapefile .shp, but sometimes we're going to use the geodatabase or the geopackage, which are also very useful for us. The other ones are not very good to work with, especially those that are Excel based, so .ods or .csv or .xls, but they work in a way. So let's start with where we stopped last week, which was visualization on symbologies for the map on QGIS. So I'm gonna open here a new um, a new shapefile with new data, and I'm gonna show you different ways that we can perform what we're gonna do today. So first things first, let me do this. I created a, let me put it in a chat. I created a folder that you can download with a lot of what we're gonna use today. It's easier for us to uh, for us that way. So if you downloaded Spatial Analysis 101 Session 3, there's the GeoDa file, so we can install it for Windows. There's the shape file. I'm gonna use my state for now for sake of time and because it's easier for me to organize data and population, and it's not gonna be so time consuming. And then data files. So we're gonna work today with alcohol abuse hospitalizations. Uh, and we're gonna map this distribution in the state. So it's easier that this way, so feel free to download it if you want to replicate later. I know that sometimes we tend to replicate with our own data and get some errors, so feel free to use this one to start doing this analysis. So the first thing I'm gonna do here is to get this shapefile out of the zip file because again the zip file is not functional, and we're gonna extract everything. I already have it done it here, so I already have it. And after that we're gonna start working with the data files. So let me put here the shapefile for Paraná State. I downloaded from the Brazilian Institute of Geography and Statistics. And of course, you can find it in the website that I showed you last week. So the first thing that we're going to start here is, let me see, just one thing here. Okay, perfect. So as you can see here, this is the attribute table. There's a lot of information. So you have the municipality code, the name of the municipality, you have this RGI and then RGINT, which are two different divisions that we have within Brazil, which is the immediate and the intermediate regions. And then, of course, you have the area in kilometers, you have the name of the region, the big regions, and then you have this one, which I don't know what it is because it's new, and I will know after the class. So what we want to do here is do what we did last week and transform this municipality code from 7 to 6 characters because we can use the 7 ones with the data source data. So I'm gonna go with the field calculator and I'm gonna create a code that is called EBGA code. I want to be a text or a string, and I want 6. And I'm gonna use the fields and values of code municipality. And I'm gonna click OK. So now I have the 6 characters code for all of this. Usually, what I would do is to clean up some of these variables because I don't need all of them. But that's also some can create some trouble to the shapefile, so that's why I'm not gonna do it today. But some of these variables that are not useful for us, I tend to clean it. So exclude this one, 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 this one. I'm not gonna do it if we're working with the whole country, but for just the state, that's something that I might do. So now we have it. And I'm gonna close this real quickly, and I'm gonna add the files that we're gonna work today. So we have the alcohol abuse data and the population data. Quick reminder, if you downloaded it, this is in the Brazilian CSV version. So it's actually a semicolon. It's not a column, so a comma. So please keep that in mind. So here we can
And
have the
Nanda,
yeah, okay.
just so folks maybe are aware as well, you were talking about the separators, right, from the text field.
Yes.
Okay.
So let me show you. Here in the file format, I entered the alcohol abuse data, and there's selected the tab and the semicolon. Let me unselect the semicolon. This is how it's gonna appear to you. So you see here that it seems like it's one single column, which is not, because it's not a comma that is separating. You see here that comma does not do anything, but a semicolon. Whenever I click here to semicolon, it creates or it organizes into multiple columns. This is important because it allows us to uh, get those different files and work with them whenever if it's a semicolon or a comma. Also, you want to go here, and if your data has any type of decimal separator, which is not the case, but it can be, you want to click here. Decimal separator is comma. If your decimal separator is a comma, if you're working with Brazilian data, because in Brazil, the decimal separator is not the dot or the point; it's the comma. So keep that in mind whenever you're working with different type of spatial analysis data. So okay, I'm gonna put this one here. And I'm gonna add, oh, one thing that is important too, the encoding, it's automatically selected to UTF-8. Sometimes not the best. So we tend to change that to Windows 1252. because in Brazil we have like accents. So sometimes it's the best one, but UTF it's the most useful for American English or any type of data that does not have any type of special symbol. So I'm gonna add this one, and I'm already gonna input the pop data as well. As you can see here, the same thing applies, and I'm gonna add as well. Then I'm gonna close. So I'm gonna open the attribute table. This one is the population. So here we have the IBGE code, the municipality name, and the population for the years 2023, 2024, and 2025. And for the alcohol abuse data, we have the hospitalizations due to urgent hospitalizations due to alcohol abuse for the year 2023, 2024, and 2025. And of course, the total for this 3-year period. We're probably going to work with the year separate. So now what we want to do is that we want to join those data into the shapefile. So we're going to go here, join. I'm going to start with the alcohol abuse data. We're going to use IBGE code from the join field, so from the alcohol abuse data, and the target field will be the one that is on the shapefile. So IBGE code. I want only those 3, so I'm gonna select here join fields and select those 3, and I'm gonna click here custom field name prefix and exclude this, otherwise this will keep popping up as the name of the variable, and I don't want it. So what I'm doing here is that I'm joining the data with the shapefile. And now I'm gonna do the same with the population data. Same thing. So you can see here that whenever I click in target field, it appears the 3 variables that are already linked. So it shows us that it was a successful joining. Yeah. So I'm gonna select BGA code again. Same thing here, just those 3 variables and then exclude this one. I'm gonna click OK. We can click apply, but I'm gonna go with OK. And you can see here, it's always good to check because sometimes it can be some errors, especially if we're working with country level data. It did work, so I have all the data here. Just confirming that we don't have any new data. Yeah, it's all here. So now I have these joined. But what you want to do is create a new shapefile. Yeah, go ahead, Joel.
Just to highlight to folks there, so Nathan browsed through the joining process, but then he added two sets of information to the shapefile. You can see the map that you're seeing. Again, just remember, this is the shapefile with the geographical information. Then he added populational data and then alcohol abuse data to that. In your research, you're probably going to have to do something similar because these informations often are coming from different sources as well.
Yes. Thank you, Joel. So this is very common. We don't usually have all the data in one single file. And I don't really like to work previously and put all of this together. I like to join them in the GIS software that we're using because first it's easier, and second it's more useful this way because then you can choose exactly what to do, And you don't need to put in the Excel and go, okay, so this one, I'm gonna link with this one, because sometimes it's very difficult. If you're working with R or any other statistical software, okay, that can be easier. But for Excel, for those that don't know how to code in R, it's easier to do this way. So now there's two options. We can work within QGIS to map, and then we can transfer this to GeoDa and work in GeoDa. So for basic mapping, QGIS works fine. How? If we go to the open attribute table, we don't have any rates here. We have the hospitalizations and we have the population data. We need to create the rates. For spatial analysis, sometimes we want to create these rates in the software because some rates are different. Some rates depends on or relies on spatial dynamics. So it's important for us to create or calculate these rates only on those softwares. So avoid including in the data that you're inputting here already calculated rates. And then by rate, I say hospitalization rates or prevalence rates or mortality rates and so forth. So now what I'm gonna do is first export this one. Why? This is joined, right? So if it's joined, it's not completely added. It's like a temporary adding. If you try to move this from this software to another software, only the shapefile information will be included. Those data, pop data and alcohol abuse data won't, because the shapefile, it's only temporary joined to this. It was not added, it was joined temporarily. So what you want to do is to export. So I'm gonna save this feature. I want this to be a shapefile. I'm gonna work with Sirgus 2000, of course, because it's a Brazilian map. And I'm gonna choose a file name. I'm gonna let you speak in a minute about it. Let me just come here. So shapefiles. I want this to be alcohol abuse hospitalizations. So it will create a shapefile within the folder that I selected. And then I usually tend to let this add saved file to map, because then if you come here, properties, you can see there is another shape file. There is nothing joined. Nothing joined. But if you open the attribute table, the data is here. So now the data is actually added to the shape file, not just joined temporarily. Go ahead, Obali.
Yeah, I just wanted to understand what the temporally means in this case. I'm not
What
sure
means?
I
Sorry.
quite understand.
What it means? What?
Yeah, like, I mean, is it like it's been joined, but it's not been saved, or, I mean, I don't get it clearly.
Okay.
Temporary, and that's on the use of temporary.
Temporarily. Okay, so you see the join layers here?
Yes.
Okay, so what's gonna happen if we delete one of those files? So for this shapefile that is temporarily joined, so you have the data here. Okay, but let me exclude this one. And I'm gonna go back here. So you can see that there's not that file anymore here joined because I excluded, of course. If we go back here, the alcohol data is gone because it was not saved.
Mm.
What we did, it's like you're working in an Excel file and you added some data, but you didn't save.
Okay, okay.
So if you didn't save, if you close it, it won't save. So after you open it again, you have to do it again.
Okay, I get it. I get it now.
That's what temporarily
Thank you.
I mean it. Thank you for the question. I'm gonna then remove all of this because if I remove all of this, this one that we saved is still with the data that we want. So it's okay. This one it's good to go. So now what we want to do is create the rates, right? Because the crude numbers don't show us anything. We want the rates to really understand what's going on. So I'm just going to do this for one single year for the sake of the time. So in the same way that we open the calculator to create the EBGA code field, we're going to go here and I'm going to create a variable called rate alcohol abuse hospitalization 23 to keep it standard. I'm going to change here to real because I want decimal numbers here because it's a rate. And I usually tend to do 20 in the output field length and 15 on precision. What it does is that the length is the maximum length of what is going to be shown of the field. And precision is how many numbers of those will be after the point, so the decimal numbers. And you will want to change these ones because it was the standard is 3, and sometimes we need more than 3. It's not the best. So I tend to put it this way. Of course, you can change it however you want. You can stick with 3. I do prefer these ones. So the calculation is simple. I'm gonna put here a parenthesis. I'm gonna add the alcohol abuse 2023, and then I'm gonna put a how does this call? Like the division bar is called division bar.
Backslash or something?
Backslash.
That's fine.
Yeah.
Yeah. This one, you can see it. So, and then you're going to add, of course, the population. So you're dividing those two. Don't forget to close your parenthesis. So this one will create the rate. And we're going to, of course, add here the multiply here by 100,000 because that's going to be easier for us to interpret. So we're going to create a basic rate here, like a hospitalization rate. So you can see here the preview is already showing us what's going to happen for this feature. So it's going to be working fine. So let's apply that. And then, okay. It's here. You can see there's a lot of zeros because there's a lot of municipalities that didn't have any hospitalization due to alcohol abuse, but you can have rates as high as 383 for Iguaraçu, which is very close to my city. So the top 3 are actually in the region of Maringá, the city that I live in. So this rate is now calculated, and with that we can, I'm gonna save, of course. This we can show in a map. So let's do this here. It's the same thing that we did last week. I'm going to double click here, symbology, and choose from single symbol to graduated. Graduated, it will create a scale. So you can see here that we have a lot of different ones. So rate, we can use quantiles. I tend, when we have a lot of zeros, to go to Jenks because the natural breaks are easier to understand. And then it classifies automatically. I want to remove the trimming, and then I'm going to choose the precision here to be 2. So the legend here, it's 2 decimal characters. So here you can see that we have big jumps from one to the other, and we usually tend to link the class boundaries. I just don't like this color, so I'm gonna change this to, I don't know.
How about VDGs?
VDDs.
Yeah, that one. I've heard that it's a good color for people that are on the colorblind spectrum, either depending on, regardless if it's and red and green or blue and yellow, it should work
Yeah.
fine.
This software does not have the visualization for blinds, for light spectrum blinds, but the other softwares like ArcGIS, they do, so it's easier. What we want here is change, so revert, because the more dark color is in the minimal values, and we don't want that. So invert color ramp. Now it makes sense to our brain. And now we can see where the rates are. So this is a map that is actually showing us something. What I like to do, as I showed you last week, is I go to symbol, and then I go to symbol fill, and I put no line. For me, it's a little bit easier. Of course, that I know the stage and so it's easier for me to know. But if you want to keep the stroke lines, it's fine. It's not the best like detail you have because you're gonna see like small white lines here, and it's not pretty. So if you have the time, you can go like to each one of those and here and like, okay, so I'm gonna change the stroke color to match exact color that we have for this. So it's a little bit prettier. But we don't have the time, so I'm not gonna do that. Okay. So as you can see here, that's a map. It's a simple map for rating. But if you want to create a special statistics map, this is not the best use of it. So because I said that the top 3 of the municipalities that are with the higher rates are in the Maringá region, which is here. sometimes what happens is that we have like a common geographic understanding. So there's the first geographic law of geography that it says something like the closer it is to an object, the more influence it has to such object. So between this city that is like neighbor of Maringá and this city, which one has more influence in Maringá city? Of course, the one that is closer. So this is something that geographers and spatial analysts want to take into account, because especially if we're talking about health-related data, because there's always a city that it's bigger or that is a center for hospitalization or for any type of service facility that we want to take into account when we're doing this spatial analysis. So what we're going to do is that we're going to change softwares now. So, okay, this attribute table has all the things that we want. Fine. Let's minimize this a little bit. And then we're going to go to GeoDa. On GeoDa, I'm going to open the shapefile that we just created. So shapefiles. I want the alcohol abuse hospitalizations. So this is a little bit different. Let me know if you want me to zoom or anything like that. And you can see here that I have 399 municipalities, which is the number of municipalities in the state. I'm going to open the attribute table. And you can see here that I have all the same variables that I had on QGIS, right? So I can even check if it's the same municipalities, the same thing, is the same attribute table. So here I have the rates. Okay. We can use a quantile map. So I want here to, let's go to natural breaks map because it's the same. So I want to use this 5 for the rate. And I want to show you this thing. Do you see it's the same exact map? Of course, different colors, different things, but the same exact map. Because it did was basically, it's a little bit different on a couple of things, but it did the same type of separation, let me call it this way. So the difference here is that this is automatically. We can actually save this image if we want. We can click each municipality. Let me go back here. So this here shows us the Paraná state map the same way that we did in the last software on QGIS. Okay, so mapping is the same. We can do that for equal intervals. We have the rates calculated map. So if we have any type of rate calculated, we can create on this exact software by putting here. So the alcohol hospitalization, the population, I want natural breaks, and I want 5 categories. It will create for me. So I don't need to calculate the rate. We can choose raw rate, which is what we did. we can calculate the excess risk. So this is a really good map that I really like. So you can see here the excess risk map. And what it does, it is creating not like a rate, but a radio that is the excess risk. So it creates based on what it is expected and the actual value and creates this excess risk. So you can interpret this the same way that it's interpreted like a risk radio. Yes, a risk radio. So you can see here that the stronger the blue, the less the risk, and is stronger the red, higher the risk for hospitalization. We can also go here and we can create a spatial rate, but it gives us a warning. GeoDa could not find the required wave file. What is that? Right now, how does the software knows that this city is a neighbor of this city? It does not. So we need to tell them that they are. And we do that going here, Waves Manager. Because we're going to put a geographical weight to that. So create, we can select an ID variable. I don't like to select one. I like to create one. It's easier and it's less likely that you encounter an error. So add an ID variable. It's called poly ID. So the ID of the polygon. We're going to add this. And then we have queen contiguity and rook contiguity. So this is based on chess. If you don't play chess, what is wrong with you? Just kidding, because I'm a huge chess nerd, so I love to play chess, which you can say just by looking at my face. But the difference here is that rook and queen move in the board different ways. So how does a rook moves? Back and forth and side to side. And queens go to any direction. So we're going to apply the same logic here. If we want a contiguity that is based on the queen moving, any direction is fine. If you want a rook contiguity, only those that are up, down, left, and right. So diagonals won't apply. So the best one, in my opinion, for countries like Brazil, is the queen contiguity. There are some countries that the rook contiguity is best, but for most of them, we're going to choose queen contiguity because even if it touches in just the corner, it's still a touching. So we want this queen contiguity. And what we try to do is to lower the precision threshold. So it's set up to, if we unclick this here, it's 0. We want to be 0.0001. So it will get even the slightest touch. Why? Because geographic mapping, it's an extension of the real world mapping, but the real world does not have limits, visual limits. Sometimes a city is so integrated into another that we can see differences. So we're going to put 0.001. And then we're going to create this one. Tend to put in the same folder that you have the shapefile, and this is a .gal file. So it was created successfully. Let me close this one. Let me go back here. So you can see that the order is 1. Good. The number of observations is 399, which is the number of municipalities. The the minimum number of neighbors is 2, and the maximum number of neighbors is 12. Symmetry is symmetric, and the type is queen. Okay. So with that, now if we want to create a spatial rate, we will be able to using the same variables. I'm just gonna go for natural breaks and 5. You can see here that it's kind of smooth. You don't have the same differences that you have here. Like, okay, so it's kind of each city, it can be a different color. Here is more like they all group together, because that's the idea behind this smoothing or this spatial dynamics, because we understand that it's not because a person is hospitalized in this city or this municipality that it won't be influenced by the others nearby. So you can see that like this one here. So we have 3 different municipalities here that have very strong hospitalization rates. But when we go to it's not working for some reason. Oh, when we check here, it's not that high because the other municipalities also has an impact. So this is a way that we can map, and it's way easier to understand geographical dynamics of health, because usually you're gonna see a pattern like this, not like the raw rates or the crude rates. So this one is the best mapping that we can show whenever we are creating a paper or trying to visualize any type of dynamic of disease or whatever. So this one of them, so this is a spatial rate. The best one is the spatial empirical base, which puts into account a Bayesian statistic. And why is it important? So I'm not gonna dive into Bayesian statistics. If you don't know what Bayesian are, what's wrong with you? But Bayesian is actually saying in a very, 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 very simplified and sometimes wrong way to say it, the understanding of something changes whenever we get new knowledge. And this applies, of course, to statistics as well. So probability changes whenever we get new information. So for mapping, this is important because whenever we understand new information on other municipalities surrounding us, that creates a new rate that it's more closer to the real world than to just statistics. So here we have a smooth version. Of course, it's not the best visualization. We don't want, quantile map. So this is a smooth one. So a smoothed one will get the number of your neighbors and mix it with yours to see if they are very different or if they are close. So it's easier for us to understand the dynamics. So if I have 0 and João Vitor have 100, why? Why is it so different if we're neighbors? It shouldn't be. So it kind of moves. I get some of João Vitor's data and he gets some of mine. And then it kind of equalizes. So it goes to, okay, João Vitor has 100, I have 0, but in actual data, I have towards 30 and he has over 80. So it's closer. It doesn't need to be like, oh, up to 100. No, it's just closer. So instead of being like this, it go like this. So almost time cap. I just wanted to show you how different those mappings or these different rates are. I cannot see the chat for some reason. There's any questions in the chat I'm not seeing. But let me know if you have any questions that I can address right now.
Thanks, Natan. I don't think there's any unanswered questions in the chat. We're just sharing some resources about color blindness, about decimal separators as well as CSV separators. So yeah, any other questions you can drop in the chat, or I see Eduardo has his hand up. You want to go ahead? You can just go from here.
Yeah, maybe I'll try this one.
Okay, let me mute this.
So, which one?
Okay. Then I have one simple question about exporting the map, the figure. I remember you once showed us that when you move the cursor over an area, you get some special information like the rate or name or whatever. Is it possible to export it this way in a dynamic way?
Export the rate.
Export the map in a way
The map.
that someone
Yeah,
can
we
move the
can.
cursor over it like HTML or something like that?
Of course. There's hard ways and easy ways to do that. Let's just with this rated calculated map, I'm gonna go with the spatial and particle base and the quantiles. Okay. I don't like this one. Let me go for the raw rates. I think it's gonna be easier for us to understand this way. So natural breaks, let's put 5 here. So this is the basic rate here that we have. What you can do is save image as. Let me see if I can, yeah, put it here so we won't get into the front of anything. And then you save it. You can choose the width, the height, the resolution. Let me put here. And if I go back, it's here. I personally don't like to do this because I think it's. What happened? Oh, okay. I personally don't like to do this because I think it's very ugly. So I tend to, whenever we're working with GeoDa, go back to QGIS and then export there. But to export there, we need a little more time that we don't have right now. So I'm not showing this right now. I'm gonna show it eventually, probably in the last session, how to export it. But there are simple ways to do it that it's just clicking, saving image as, and then putting here, showing legend or not, transparent legend background, whatever. The thing is that with this software, GeoDa, we don't have like a scale bar or a north arrow, which is important for us to really visualize and have a real map, because without those symbols, we don't have a map. So QGIS will allow us to do that, but GeoDa won't. So to export the easiest way, this way, for like an SAP or to just show the results, but for the actual paper, we need more time because it's a little bit more complicated and needs to be more complicated. Did I address your doubt question?
Okay, thank you very much. I'm eager to go to your last talk and see how this happens.
Yeah, let me yeah. I think that was it.
Awesome. Well, we are out of time. So I want to thank Natan again for presenting to us and preparing all this great information. We always know where to find you. Again, this will be on YouTube, so you can find it. Leticia has been sending out to the listserv the recordings for if you missed these or want to go back to them again. And let's see, we'll be back again on April 7th with ArcGIS about creating and manipulating vectors. So that is our next chapter. Thanks everybody for joining, and thanks again to Natan for presenting with us.